Hello student, my name is Laukik Raut. I am an assistant professor at G.H. Raisoni College of Engineering, Nagpur. In this lecture, I am going to study you dynamics of machine. So before that, we have to understand what exactly the dynamics of machine. So earlier in university, the name of this subject was theory of machine. The theory of machine is divided into two parts, that is kinematics of machine and dynamics of machine. So dynamics of machine. Okay, so this so first of all, theory of machine, it is divided into two parts, that is kinematics and second one is dynamics. Okay, so theory of machine, it is divided into two parts, kinematics of machine and dynamics of machine. So basically in kinematics of machine, we are interested in motion of the object or the motion of various links into the machine, and in dynamics of machine, we are interested in the motion of the links as well as the force which are acting on the various links of the machine. So basically in kinematics of machine, we have neglected the force which is acting on the machine member, whereas in dynamics of machine, we are considering the force which is acting on the various links. Okay, so first of all, before understanding dynamics of machine, we have to understand what exactly the machine is. So machine is nothing but a mechanical device which receives the energy into some form, okay, and convert it into another form. Suppose we can take the example of fan. The fan accepts the energy into electrical form and it converts it into mechanical energy. Or there are another example of machine like turbine is also there. So in turbine, the turbine receives the energy in form of hydraulic energy and converts it into electrical energy. Okay, and we can take the example of pump also. It receives the energy in form of hydraulic energy and converts into mechanical energy. So that is an example of various machines. Okay, then we will consider. Okay, the machine is made up of various links. So what first of all we have to understand what exactly the link is. The link is nothing but the link is nothing but the machine is made up of various links and that link has the relative motion in between them. So we will take an example of 4-bar mechanism. Okay. So this is known as 4-bar mechanism. Suppose this is point A, this is B, this is C and this is D. Now in this mechanism, the link AD is fixed, whereas link AB, it is a rotating member. It rotates about point O. This link is also known as crank. Okay, this is known as coupler. This is known as coupler and this part is known as rocker. Okay, so every machine is made up of various mechanisms and that mechanism is made up of various links. So this portion is known as link of that mechanism. Now when you connect these links, you will get a kinematic pair. Now link AB is connected with link BC. So this forms a kinematic pair. Link BC is connected with link CD. This is also known as kinematic pair and link AD is your fixed link. So when you connect these kinematic pairs or this kinematic link alternately and first point is joined to last point, then you will get a kinematic chain. Okay, and when one of the link of a kinematic chain is fixed, then it is known as mechanism. And the method of obtaining different mechanism by fixing different link, then that process is known as inversion of mechanism. Okay, so in dynamics of machine, what we are dealing with the forces acting on this link. In kinematics of machine, we are interested in motion of each part of this link. So now this is the crank, this will rotate about point O. So it has a rotary motion and this link is known as rocker. So this rocker this rocker has oscillatory motion, right? And in kinematics of machine, we are interested in rotary motion and oscillating motion. But whereas in dynamics of machine, we are interested in the forces acting on these links. Suppose this is a crank, it has a rotary motion. So there will be a force which is perpendicular or tangential at this point, right? So we are acting a torque over it. That torque is nothing but a product of force and the perpendicular distance, and this force will be transmitted to this coupler, right? And then from this coupler, this force will be transmitted to rocker. That means we are interested in the force acting on these links. Now, why it is important to calculate the force acting on this link? Because after calculating the force, we can calculate the stresses which are acting on this part. And why it is important to calculate the stress? Because on the basis of that stress, we can design this link. Because in order to design a particular component, we have to calculate the forces which are acting and the stresses which are acting on these members. Okay. Now, why it is important to calculate the stress? On the basis of that stress, we have to compare that stress with the strength of this material, because the design process starts with what? First of all, we have to select the material, and that material will be selected on the basis of strength of that material. So first of all, we will calculate the stress. Suppose the torque is acting on this crank, okay. Due to that torque, the force is acting on this coupler, and now we are interested in designing this coupler. So first of all, we will calculate the force, okay. That force we can calculate from the torque. Then from that force we can calculate the stress. So first of all, we have to understand what exactly the stress is. Stress is nothing but, suppose one member is there and you are applying a force over it. Suppose this is a member and you are applying a force over it. So this member will resist that force. So that resisting force per unit area is known as stress. Okay. So now we will understand what exactly the stress is. So I have already defined you the stress. This stress is classified into several types. Okay. First one is, suppose, tensile stress. Okay, suppose one body is there, and on this body, suppose you are applying a force which is equal and opposite, and which is parallel to this face. Now this force is equal and opposite. You are applying the same force on these two faces. So equal force is there and it is opposite. Then this force is perpendicular to this portion. Now the stresses inside this body is known as tensile force. Second is compressive stresses. Okay. In compressive stresses, suppose one body is there and on this body you are applying a force which is equal and opposite, and you are compressing that body. That time the stresses generate inside the body, that stresses is known as compressive stress. Okay. And third one is shear stress. Now in case of shear stress, suppose the body is fixed, and you are applying a tangential force, due to which this body will get deformed. Likewise, and that shear stress will be defined by the parameter phi. Now after calculating these stresses, we can design this component. So before that, we have to calculate the force. From that force, we can calculate the stress. The formula for calculating the stress is force upon area, right? So on the basis of this force, we can calculate the stress, and this stress we will compare with the strength of this material, and on the basis of that we can design this component. Okay. Then again we have to understand the behavior of material, that is very important. So for that we have to understand the stress strain relationship. Okay. Suppose on y axis I am taking stress, and on x axis I am taking strain. Okay. So this point is known as proportionality limit, suppose A. This is elastic limit, okay, B. Then C is upper yield point, D is lower yield point, and E is suppose ultimate stress, and this one is fracture. So this relationship we have to consider before designing the component, because this is a stress strain relationship for a mild steel, and mild steel is a ductile material, and because of that we are getting two yield point, upper yield point and lower yield point. So stress at this point can be denoted by SYT, whereas stress at E point can be denoted by SUT. This is known as yield stress and this is known as ultimate stress. Okay. Now I am plotting one more diagram. Again on y axis I am taking stress, this is strain. Okay. Now this is known as fracture point. This is for what? This is for brittle material. This is for brittle material. That means I have to understand what type of material is. If it is a mild steel or a ductile material, then I will get the profile like this, where the point is known as your proportionality limit. Up to this point stress is directly proportional to strain. Then I am getting elastic limit, then upper yield point, lower yield point, then there will be ultimate stress, and finally the fracture. That means suppose I am applying a force over this component. First of all, what will happen? There will be yielding, that means there will be a reduction in area. So at this point neck formation will be there. Okay, that is why this material is ductile in nature. So this material will not break after the application of force. But in case of brittle material, when I am applying the force, there will not be any yielding phenomena. Here you will not observe any yielding phenomena. This material will get fracture after applying a force. Okay, so this is for brittle material. Now that is why dynamics is very important. In dynamics we are considering the force. From that force we will calculate the stress, and this stress we will compare with the strength of this material. Now we will discuss the syllabus of dynamics of machine. Okay, so first of all, the first unit that is related with, the first unit is under static and dynamic analysis. Dynamic analysis. So in static and dynamic analysis we will study the various forces acting on the link. In static analysis we will consider that this mechanism is in equilibrium, and then we will calculate the forces acting on each link. Then in dynamic analysis we will consider the inertia forces which are acting on this link. Then second unit is all about the turning moment diagram and flywheel. Flywheel. Okay. Second unit is all about turning moment diagram and flywheel. So flywheel is nothing but an element which stores the energy when there is excess of energy and which gives the energy when there is requirement. That is all about flywheel. Then third unit is about balancing of rotary masses. Okay, balancing of rotary masses. And the fourth unit is about balancing of reciprocating masses. Okay, and then in fifth unit there is longitudinal vibration, and in sixth unit you will study torsional vibration. Torsional vibration. So first unit is all about static and dynamic analysis of forces, and second unit we will focus on the flywheel. Flywheel is nothing but a element which receives the energy when there is excess of energy and which delivers the energy when there is requirement of energy. Suppose if we consider the working of IC engine. So in IC engine basically there are 4 strokes: suction, compression, expansion and exhaust. So during suction, compression and exhaust stroke we are not getting any kind of energy, we are getting energy only during your power stroke. So that excess energy will be stored inside the flywheel and that will be supplied during suction, compression and exhaust stroke. Then third unit is all about balancing of rotary masses, and fourth is balancing of reciprocating masses. So every machine it is made up of certain rotary masses and reciprocating masses. So we have to calculate the forces which acting on the rotary masses and the reciprocating masses, and then we have to balance it, because if it is unbalanced then there will be a vibration and it will causes noise in that machine. Then fifth and sixth unit is all about vibration. Vibration means suppose this is the component, it is in equilibrium position and I am applying a force over it, due to which it is get displaced from its equilibrium position, and again it will try to come back to its equilibrium position. So that phenomena is known as vibration. That vibration is classified into longitudinal and transverse vibration and torsional vibration, that we will study in sixth unit. Okay. So this is all about dynamics of machine. The next part we will discuss in next lecture.